Hi everyone, today let's talk about section 10.2, polar coordinates. Big idea. A new coordinate system that locates points by their distance from the origin and direction in standard angle measures is an alternative way to describe the graph of equations. The advantage of using this new system is that many equations become simpler in these coordinates, and there are many beautiful graphs that arise that you wouldn't imagine using the XY coordinates. Big skills. You should be able to switch between polar and rectangular coordinates. So XY, we call them rectangular coordinates. And the polar coordinate, we use r and theta. Okay, for our points on the plane, and sketch the graph of polar equations. Definition. The polar coordinate system is a two-dimensional coordinate system in which each point on the plane is determined by a distance r from a fixed point O that is called the pole or the origin, and the angle theta from a fixed direction. The point P is represented by the ordered pair r and theta, and r and theta are called the polar coordinates. So we extend the meaning of polar coordinates to the case in which r is negative by agreeing that the points minus r theta and r theta lies in the same line through the origin and at the same distance r. Okay, absolute value of r from the origin, but on the opposite side of r, so of the origin. So if r is positive, then the points r and theta lies in the same quadrants as the theta. If r is negative, then it lies in the quadrants on the opposite side of the pole. Okay, so now let's say this is our point P. R is the distance from the point P to the origin O. And theta is the angle made with the positive x-axis. Okay, counting counterclockwise. Okay, so that's why if you have an angle here, theta is positive, but if you have an angle here, then the angle is negative. Okay, and so when r can be negative, so it's just like we're on the same line, but we just go backwards. Okay, so this angle, this point is now negative r theta. You can also think about this guy is the angle is theta plus r. Theta plus pi, okay, because pi is 180 degree, okay, so the angle is theta plus pi, but your r is the r, okay, so you can think about is the angle theta plus pi, and then you go forward r distance r, okay. So in xy plane, each point we have a unique representation, but however, for the polar coordinates, a point could have many different representation. Okay, let's look at examples. Example 1, plot the points whose polar coordinates are given. Okay, so let me use, okay, so this is the x-axis and this is the y-axis. Okay, so here we have the r is 1, and the theta is 5 pi over 4. Okay, so this guy corresponds to 0, theta is 5 pi over 4. So 5 pi over 4 is like pi plus pi over 4. So we know pi is this guy, right? And pi plus pi over 4. So this is the angle theta. Okay, and we go forward 1 unit. So let's say this is 1. Then this is the point 1 and 5 pi over 4. So far so good, everybody? Okay, how about the part B? So I hope you can practice doing it, and then you can go over the answer with me together. Okay, so first we look at the angle 3 pi, well, we know 1's around is 2 pi, so 3 pi is still this guy. So that's why we are here. Okay, and we go forward 2 units, 1, 2. So actually This is 2 units. And this point is -2, 0. Okay? So this is the point. This is the point 2, 3 pi. So far, so good, everybody? Okay, and then next part C. Okay, so first of all, our angle is negative. Negative means you go clockwise instead of counterclockwise. So you go clockwise for 2 pi over 3. So, you know, this guy is pi, and then, so 2 pi over 3, you divide it into 3 pieces. Then we know this guy is, let me draw it better. Okay, so we have this guy is the angle -2 pi over 3. Okay, and we go forward 2 units, 1 and 2. So this is the point. So far, so good, everybody? Okay, let's continue. So angle is 3 pi over 4. So 3 pi over 4 is here, right? That is 3 pi over 4. And, wow, our R is negative. What does that mean? You don't go forward, you don't go this direction, but you go the opposite direction. Okay, so we go to the opposite direction. Okay, for 3 units. 1, 2, 3. So this is the point. This is the point -3 and 3 pi over 4. Okay, so this is about given the polar coordinates, how do we plot on the xy plane? Okay, let's look at example 2. Find all the polar coordinates for the points 2 and pi over 6. Okay, so let's draw pictures. Okay, so first we look at the angle. We always look at the angle first. So the angle pi over 6, positive, so we go counterclockwise. Well, pi over 6, well, is like you have this is a pi, and we divide it into 6 pieces. So it's the same as like pi over 2, 90 degrees, you divide it into 3 pieces. So that's it. And so we know this is pi over 6, okay? And we go forward 2 units, okay? So go to that direction 2 units. So that's why we have this angle. So this point is 2 and pi over 6. Okay, how do we find all the polar coordinates for it? Well, we know this point, we can add 2 pi to it, then we have the same angle, right? So it's actually 2 and then pi over 6 plus 2k pi, right? So when we add 2 pi, we have the same point, or we can subtract 2 pi, then we still have the same point. So that's why here k is any integer. Okay, so far so good. Oh. Okay, and then there is another way we can express it, is by thinking about this angle. So what's this angle? Oh, this is like pi plus pi over 6. That is 7 pi over 6, right? And then what do? You go backward 2 units. So that is -2 and 7 pi over 6. Okay? And, well, you can also include all the angles. So you add 2k pi to it, and k is any integer. So in that case, you include all the polar coordinates of this point. So far, so good, everybody? Yeah, so you can see from the example 2, we can see a point. We don't have unique representation of the polar coordinates. A point can have infinitely many representation of the polar coordinates. Okay, so next, let's talk about the connection between polar and Cartesian coordinates. So Cartesian coordinates also called the rectangular coordinates. It means xy, okay? So which is, let's look at the figure below, okay? The x is the distance, the horizontal distance from the origin to the point, right? Y is the vertical distance from the origin to the point. And R is the distance from the origin to the point. And then you can see they form a right angle triangle. Okay, so think about the relation, okay? So think about the relations here when we have, let's say we have polar coordinates on theta. How do we get the rectangular coordinates, which is xy? Okay, we use x equals to r cosine theta and y equals r sine theta. Well, because, you know, sine theta is the opposites over hypotenuse. Okay, so y is then r times cosine theta. And cosine theta is the adjacent over hypotenuse. So x is then r cosine theta. Okay, so given the rectangular coordinate system, how do we get the polar? Well, we know r squared equals to x squared plus y squared. So r is then square root of x squared plus y squared. And because r tangent is, tangent theta is y over x, then theta is gonna be arctangent. But you gotta be careful, okay? So it's arctangent of y over x if theta, so if the points, okay, if the point is in the first quadrant, okay, if the point is in the second, okay, if the point is in the second or the third quadrant, then because the range of arctangent only covers minus power 2 to power 2, so that only covers the quadrant 1 and quadrant 4. So if the point is in quadrant 2 and quadrant 3, you actually need to add pi to it. So to figure out your theta, you actually need to look at where is the point located. It locates at quadrant 1 or quadrant 4, and then it's just arctangent. Okay, and if the point located in quadrant 2 or 3, you need to add pi to it. So theta is pi plus arctangent of y over x. Sometimes some textbook, they would like to make the angle always positive, so that's why in the fourth quadrant they add 2 pi to it. So then that angle is positive, okay? Because in the fourth quadrant, your arctangent, you get like from minus power 2 to 0. So when you add 2 pi, then you get a positive angle, okay? So let's look at example 3. Convert the points from polar to Cartesian coordinates. Okay. All right, so r is 2, theta is 3 pi over 4. Okay, then what is x? Well, x is r cosine theta, so which is 2 times cosine 3 pi over 4. Are you familiar with the angle value? Cosine, what's cosine looks like? Like that, right? And 3 pi over 4 right here. So that is negative of, like, cosine of pi over 4 is root 2 over 2. So it's negative of root 2 over 2. Okay, so that's why we get negative root 2 for x. How about the y? Well, the y is r sine theta and sine of 3 pi over 4. What is the picture for sine? So 3 pi over 4 here. Okay, so it's actually the same as sine of pi over 4, which is root 2 over 2. So the answer is root 2. So the points, the Cartesian coordinates is negative root 2 and root 2. Okay, so that is our answer for part A. How about part B? So represent the points with Cartesian coordinates in terms of polar coordinates. So I suggest you to plot the points. Okay, 1 and negative 1. So 1 and negative 1 here. This is the point. What's the r? Well, Well, r is then square root of 1 square plus minus 1 square. So that is square root of 2, right? And what is the angle? What's the angle? So you can see this is in the quadrant 4. So in quadrant 4. In the quadrant 4, we can just do arctangent of y is minus 1 over 1. Arctangent of minus 1 is negative of pi over 4. Why is that? What's the picture of tangent? Well, this is a picture of tangent. And then the x values of the arctangent correspond to the y value of the tangent. So the y is negative 4. What's the corresponding x value? Yeah, negative pi over 4. So one of the polar coordinate representation would be square root of 2 and minus pi over 4. Of course, you can think about other representation. You can add 2 pi to the angle. So you can have this guy, 2 pi minus pi over 4 is 7 pi over 4. Or you can think about the angle is, I can do like 3 pi over 4 is like here. It is like here, but I go backwards root 2 units. So that's why we get the other representation. So far so good, everybody? Okay. Let me use this notation. Okay. All right. So example 4. Express the equation x equals to 1 in polar coordinates. So this equation is xy equation, okay? So how do we express in terms of polar coordinates? Well, what is x? Oh, x is r cosine theta, and then we get r cosine theta equals to 1, right? Sometimes if you see r, if you are able to solve r in terms of theta, please do that. So you can see here r is then 1 over cosine theta. 1 over cosine is actually secant. Okay, so now you can see r is a function of theta, is secant theta. Okay, part B, express the equations x squared equals to 4y in polar coordinates. What is x? Well, x is r cosine theta, right? And square equals to 4 r. Y is r sine theta. So keep that in mind. So let's square. Okay, so r squared cosine square theta is 4r sine theta. Okay, let's move everything to the left. Then we have r squared cosine theta squared minus 4r sine theta. And let's filter out the r. So we have r cosine theta and then minus 4 sine theta. So this is square. Okay, and what happened? Okay, so here we want to make it interesting, right? So that's why so this guy give us r equal to 0, and this guy we get r cosine square minus 4 sine theta is 0. So we get r cosine square equals to 4 sine theta. R equals to 4 sine theta over cosine square. See, we can get a function, and what happened? You can actually see this guy contains r equal to 0, because when theta equal to 0, sine 0 is 0, cosine 0 is 1. So when theta is 0, we already get r equal to 0. Okay, so this guy already contained that. So our answer is this guy, and it also equals to, we can think of this as sine over cosine, which is, so we can think of this as sine over cosine and 1 over cosine. Then this is 4 tangent theta and secant theta. You can also keep this guy, keep the old form. It's okay. You don't need to express as this guy. So they all work. Okay? So that is part B. So let's look at example 5. Now, Now, given the polar equations, how do we get the xy equation? Well, let's see. Okay. So the previous example, when you see x, you just replace x by r cosine theta. When you see y, just replace y by r sine theta, and then you can play with the algebra and a little bit and simplify it. But here is actually more harder, okay? So r, when you see r, what do? You can see, let's look at this guy. So r, you have r on the left, and then you have sine theta on the right. But you kind of want to create r sine theta because that will give us the y. Okay, so you hope to see r cosine theta because that is x, and you hope to see r sine theta because that is y. So let's multiply by y on both sides. Then we have multiply by r on both sides. Then we have r squared is 6r sine theta. Wow, r sine theta, yay, that is y. And the 6 still there. What is r squared? Well, r squared is actually x squared plus y squared. See, now we get a xy equation. Okay, part B, r equals to 2 plus 2 cosine theta. So we hope to see r cosine theta. So let's multiply by r on both sides. Then we have r squared equals to 2r plus 2r cosine theta. Yay! R cosine theta, that is x. And then the rest, we have 2r. R squared is x squared plus y squared. So far, so good, everybody. We still have r there. Well, it's okay. R is then square root of x squared plus y squared. Okay, so that's why we get x squared plus y squared equals 2 square root of x squared plus y squared equals to, plus 2x. So far, so good. Sometimes people want to get rid of the square roots. So people would subtract the 2x on the other side, and then they get 2 square roots of x squared plus y squared. They're gonna square both sides, so they have x squared plus y squared minus 2x squared, and 2 squared is 4. Then now they can get rid of the square roots. Okay, so sometimes people would do that just to get rid of the square roots. Okay, so we get an xy equation. All right. So next, let's briefly go over the rest. Okay, so circle in polar coordinates. Well, r equals a describe a circle centered at the origin. So remember the circle centered at the origin would be x squared plus y squared equals to, here the radius r. So you can see this formula is more complicated. It's degree 2. But here, if in the polar coordinate, it's much easy. It's just r equals to a. It's a constant function because we have constant r, right? And for the circle center at 0a, the expression is going to be r equals to 2a sine theta. And for the circle center at the x-axis, if this is a, then the equation is going to be r equals to 2a cosine theta. Okay, so you don't need to memorize all of these. Okay, so this is just give you some example and what it's going to look like. Okay, so how do we graph the polar equation? Okay, so first of all, you consider this is like the t-axis and this is the y. Okay, so you think about y equals f of t. Okay, so 1 plus sine t is like your sine function, you shift up by 1. Okay, and then keep that in mind. Well, let's look at this. You start with the angle theta is 0. So this guy, theta is 0. So now theta is 0, the y is 1. So you plot this point. Okay, and then you think about, okay, when theta equals pi over 2, my y is 2, so that's why you plot this point. So, and then my theta, when my theta is pi, then we get here we get y is 1. So when theta is pi, we're at this direction and we go 1 unit, then this is the point. Okay, and when theta is, what's this point? 3 pi over 2, we get 0. So we're at this point. So you connect them smoothly, then you get this shape. Okay, and here, yes, so you graph r equals f of theta if r and theta were Cartesian coordinates, okay, with theta on the horizontal axis and r on the vertical axis, and then use the Cartesian graph in step 1 as a guide to sketch the points on the final polar curve, and then you connect them smoothly. And so here, 3 sine 2t, okay, so this guy, you know, this guy, this is sine, right? When you have sine 2d, what do? You actually compress it by a factor of 2. So, no, so this guy is pi over 4, okay? Then, but when you plug in it, you get 2 times pi over 4 is pi over 2. Sine pi over 2 is 1. So this is 3, okay? So at t equals, by the way, at t equals 0, you get 0. So, and this direction, you get 0. And for this direction, you get 3. So you go forward for a factor of 3. So this is 3. And then here, this is pi over 2, you get 0. Okay, so this direction, you get 0. And, okay. And then this is 3 pi over 4, okay, is like this direction, and we get -3. So -3 actually means this point, okay? So it's this point. So the graph looks like this, and you go this direction, you go that direction, and you go this direction. Okay, everybody? So this will correspond to theta equals 3 pi over 4. This guy corresponds to theta is pi over 4. And then when it's pi, we get 0. So when it's pi, we get 0. And then here, 5 pi over 4, we get 3. So it's this point. This corresponds to theta is 3 pi over 4. And then here we get theta is 7 pi over 4. So like I said, it's like this, but it go to the 4th quadrant, and you go to the 3rd quadrant, and you go to the 2nd quadrant, and go backwards. Okay, so this is how you graph the polar curve. And we also know some symmetry in the polar curve, okay? So symmetry about the x-axis. Well, we know that if r and theta, so r theta is on the graph whenever r minus theta is also on the graph. So it's like this point is r theta, and r minus theta, well, minus theta means you go you go clockwise, okay? Theta is you go counterclockwise, minus theta you go clockwise, okay? Then this point is also on the graph. Then it's symmetry about the x-axis. Okay, symmetry about the y-axis is, so if you have this guy and then you have this guy, right? This guy is r theta. This guy is then the angle, it could be pi minus theta, and you still have r, okay? You can also think of is like your angle is minus theta, but you go backwards r. So this is also you can think of the angle is minus theta, we go backwards r distance. Okay, so that's why this guy is also on the graph. Symmetry about the origin. So you have this point is theta, then you require this point is also on it. Well, then this point, it could be the same angle, but you go backwards for r units. Or it could be the theta, the angle could be you add pi to theta, so theta plus pi, and you still have your r. Okay, so this angle you go forward r units. Okay. So that's why here we have this point and this point is there. So they're both on the graph. And then we have symmetry about the origin. Okay. So here I give you more examples how to graph it. Here you have, this is r squared. So when you take the square roots, you get plus or minus square roots of 9 cosine theta. Okay, so the blue line is the positive, the green line is the negative. Okay, so when you plug into the polar coordinates here, so here we have pi over 2, right? And at 0, you put in 0 cosine 0 is 1, and you get plus or minus 3, so you get this point and this point, right? And when you plug in theta is pi over 2, that's 0, so you get this point. And then when you connect them smoothly, and this is the picture you see. Okay, if you want to know more, okay, then you can think about, okay, pi over 4, cosine pi over 4, that will give us root 2 over 2, and then you take square root of that. It's some number smaller than 1. So at pi over 4, you get positive and negative, that small number, that number smaller than 1. Yeah, so you multiply by 3, then it is a number smaller than 3. Okay? All right. Example 9. Okay, so this is the butterfly curve, and what you do is you first plot the function with the theta be the horizontal axis and the r to be the vertical axis, and then you can plot the corresponding polar curve. Okay. And you can same thing here. You first grab the function on the xy coordinate and imagine at each of the theta and plot the points. And like I said, you can work on the extra credit project, the GeoGebra projects. Okay, so we can look at the GeoGebra projects. You click the function, and then you can then here you can plot the polar parametric equations. So the parametric equation, f is like your r, right? Then x is r times cosine t. So it's whatever function for r you multiply by cosine t, that is the x. And for the y is r times sine t. So whatever function for your r, so this is the r. Okay, whatever function and times sine t, that is the y. Then you can plot the polar curve. Okay, so you can work play with the GeoGebra calculator and plot this beautiful graph. And once you get the projects, don't forget to share it to public and email me the link. I will post your projects on our website so everybody can appreciate your work. Okay, next, we're going to match the polar equations with the graph labeled from 1 to 6. Okay, so how do we match? Well, okay. So first of all, you can find you can plot some points and identify them, right? So let's see. So first of all, if you see sine and cosine in the expression, it's gonna be a periodic function. Okay, it's gonna kind of repeat. Okay, So you can see this picture, it kind of repeat because it's symmetric, okay? So it's like 5. You can divide the angle into 5 pieces. So you're gonna expect your expression is gonna contain some 5 theta inside the sine or cosine. So then it's like it's repeated for the period is like 2 pi over 5. Okay, so let's pick some points. Okay, so let's look at the first one. What does the first one tell us? Well, the first one, when we plug in 0 is 0. When we plug in pi, we'll get a sine of pi over 2, which is 1. So it passed through the points pi and 1. Okay, let's see which graph passed through pi and 1. So pi, this is pi, okay? Where is 1? 1 is right here. Does it pass through this point? No, so not this one. Does it pass through this point? No, so not this one. Does it pass through this point? No, then not this one. Okay, next, does it pass through pi and 1? Where's 1? Somewhere here. Okay, it's here. Okay, so it does not pass through that point, so not this one. And obvious, let's see. Okay, so obvious, not this one. Okay, so let's look at this one. Yeah, so this one works because this point is exactly 1, right? So 1 pi. So by reviewing the cases, we know the last picture is our first equation. So that's why our last picture corresponds to the first equation. Okay, and then let's look at part B. Well, part B, so I will think about making more interesting. So think about theta equals to 2 pi. Let's see. So if theta equals to 2 pi, and then we have sine of 2 pi over 4 is pi over 2, so is 1. So 2 pi, it corresponds to the points 1 and 2 pi. Well, but that's the same as 1 and 0. So it passed through the, sorry, this is r theta, okay? So the angle is 0. The angle is 0, and it goes forward 1 units. Yeah, so it's also correspond to 1 0. Okay, let's see. Do we have 1 0 here? No, so not this graph. Do we have 1 0 here? Oh, yes. So it's actually here. Okay. Oh, okay. So so you can see this, I just realized this picture also passed through 1 and pi, okay? So A and B is actually quite similar. So which one is for A? Well, we need to pick one more point to distinguish R and theta, okay? So how about we plug in, let's see. Okay, so what's the difference? Let's see. Okay, so if I plug in pi, when I plug in pi in the B, I get pi, and sine of pi over 4 is root 2 over 2. So at pi is actually root 2 over 2. Oh, right here. This is root 2 over 2. So that's why we see this is B. So far, so good, everybody? So by 2 points, we can figure out this is B. Okay, and here you can see the last picture, it does not pass through pi and root 2 over 2. There's no other points here. So, yeah, that's why we can distinguish A and B. Okay, next, sine squared plus sine cube 5 theta over 2. Okay, how do we know which one? Okay, so here we can see when theta equals to 0, we get 0. When theta equals to, let's see. Okay, what is it at? So at most it can get this is bounded between 1 and -1, right? This is bounded between 1 and -1, so it can at most get to 2, right? This expression is quite more complicated than the rest, so let's figure out the rest first. Okay, sometimes we can see, oh, this is complicated, maybe it's better to figure out the rest and then rule out the cases. Okay, part D, theta times sine theta. All right, this is good. When we plug in pi, let's plug in pi. Sine pi, what's sine pi? Oh, 0. When I plug in, oh, let me use different colors so then you can see how do we think. Okay, so plug in pi, we get 0. But when we plug in pi over 2, sine pi over 2 is 1, so we get pi over 2. So let's see, 0 pi, so pi we get 0, and pi over 2 we get pi over 2. Let's see, pi over 2 is here. So pi over 2 is 1.7. So this is 1, this is 2, 1.7 is right here. So it does not pass through. So not this graph. Here, it has no points on the pi, so not this one. And here, let's see. We have pi over 2, pi over 2. Pi over 2 is between 1, it's like 1.7. So 1.7 is right here. Oh, we don't have a point here, so not this one. Here, 1.7 right here. So, okay, so we have a point there. Good, okay. So, you can see that is our part D then. And also at pi is 0. So see, no points on this piece. Okay, no points on negative x-axis. Okay, so we get that is D. How about E? E1 plus 4 cosine sine theta. Let's plug some points. Okay, let's plug in, let's see. If we plug in pi over 5, we get cosine pi over 5. Well, that is cosine pi over 5 is... Sorry, pi over 5 times 5 is pi. Cosine pi is -1. So -1 times 4 is negative 3. Right? So -1 times 4 is negative 4. So 1 minus negative 4 is negative 3. So pi over, let's see here. Oh, we can also plug in 0. Cosine 0 is 1. And then we have 4 and 1. That's 5. Okay? So let's see. Oh! 5, 0. So we don't quite see this point. Okay? But this picture, you can see 5, 0 is right here. Okay? And the 5 pi over 5 is somewhere here. Okay, and we get negative 3. So negative 3 corresponds to this point. Okay, but you can just see from the point 5, 0, then we can rule out many cases. So we get this guy is E. Okay. And 1 over square root of theta. Well, think about if theta is 1, 1 over square root of 1 is 1. So theta is 1 was 1. 1 is between, so pi is 3.14. 3.14, yeah. So pi over 2 is about 1.7. Okay, and then pi over 4 is less than 1. So 1 is somewhere here. So that's why you can see the points here. It passed through 1, 1. So if theta is 1, you get 1. Okay, and when your theta increases, when your theta increases, well, this guy, your R actually decreases. So you can see here, when your theta increases, your R decreases. So that's why we can know F is the first picture. Well, but so what's left? The last picture is the fourth picture. Oh, that must be C. Okay, and let's look at the equation C. So sine and sine cube, so that oscillating between 0 and 2. So that's why this is 2. So all the graph is lies in this range, 0 to 2. Okay, and the 5, you can see 5 have, so it kind of give us like these pieces. Okay, all right. So, and like I said, you can always plug these functions into our GeoGebra calculator, and then you can draw these beautiful pictures. Okay. So that is session 10.2. So however, for our course, I won't ask you to graph the polar curve. Okay, the polar curve of the graph of the polar curve will be given, and I will ask you to compute the derivative, the arc length, or the area. Okay, so which is in 10.3. So 10.2 is just like give you some idea about what's polar coordinates, so it's kind of prepare you to go to 10.3. Okay, so the actual problem I will test on in the final exams will be the 10.3. All right, bye.